Okay, what we're going to start with today is the simple rules for naming organic compounds. And it's basically the number of carbons, okay? If you look here, these are all out of your book. I just copied this and put it in here. But when you're trying to name this substance, you can see 1, 2, 3, 4, 5 carbons. And over here, and we'll just go up to 10. There's more after 10, but we'll just stop at 10. But well, look, the prefix for 5 is pent, and these are all single bonds. If they're all single bonds, it ends in A N E, because remember that's an alkane. Okay. If you've got down here, they show if you have other things going on, like, and I'm going to show you, you can put substitute groups on there. You have to number your carbons because if there's something going on, you have to say where it's at. So they call it, if you look in rule number 3, it says assign a locator number, indicating where it can be where a bond is, it can be where a group is, whatever. So when you're using this symbol, you have to number them. And sometimes you have to start from this side. You want the smallest numbers. I know that gets a little weird sometimes, but when you look at it, like if I had a group right here, I wouldn't say it was on the 4th one. I would say it was on the 2nd one. And I'll show you more of those. Okay. So when you're writing an alkane, which again is all single bonds, or a cycloalkane, which is a ring, you got to remember that an alkane has a tetrahedral shape because you have 4 carbons and they have 4 things attached to them, if you remember your VSEPR. So there's simple notations for the skeleton. There's actually 3 different ways of writing out organic structures. Okay, this one is called the Lewis structure, where you write the carbon and you write all the hydrogen around it. Okay, this is kind of the one I do most often. So instead of writing CH3 like this, you just write CH3. And then this one would be C2, 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 and the end would be C3. That's how I tend to write it. You can, I mean, if it doesn't make sense to you this way, and you'd rather just write out the lines, because remember, every carbon has to have 4 lines attached to it. Okay, you could write it out this way. There's a condensed way. This one you don't see very often. And the other one you'll see, and I'll show you in a minute, is what they call it's a skeletal line, and I'll show you that one in a minute. Okay, it's right here. Okay, this is every time, this is a carbon, this is a carbon, this is a carbon, this is a carbon, and this is a carbon. So this would have 1, 2, 3, 4, 5. And then there'd be a group here on the 2nd one, and there'd be a group here on the 3rd one. So every time it changes direction, that's a new carbon. And this is, like I said, this is the real skeletal. You can see right here, here's pentane, 1, 2, 3, 4, 5, and it's just bung, 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 bung. You don't put in the hydrogens. This is what it would look like if you did a model, a stick model of it. But again, it's just an easier way. I tend to do this one. I just think this one gives you the information. You'll see them like this, but again, remember, this is really the simplest way of doing it. You're not putting in the hydrogen. Every time you bend, you have an oxygen. I mean, you have a new carbon. And you can see how double bonds are in. You can see other groups are in. But so that's called the skeletal. Okay. So if we're going to write these out, remember we have straight chains. That's an alkane with single bonds. And or if they're in a ring, they're joined together, and that's called a cyclo. You just put the word cyclo in the front. Okay. So if it was pentane and it was in a ring, it would be cyclopentane. Okay. So here's all the different ones. If there's 3, yeah, 3 is the least amount. You can't have 2 or 1 in a ring, obviously. You have to have at least 3. So here's, you can draw it like this if you want. That's cyclopropane. There's cyclobutane, which is a box. Lovely house is cyclopentane. Cyclohexane. This is real common. Cycloheptane is a little weird to draw because you only got 7. And here's cyclooctane, which is a stop sign. But every corner is a carbon. So 1, 2, 3, 1, 2, 3, 4, and so on. So if they're in a ring, you just put the word cyclo in the front. You still use ANE on the end. Okay, cyclo, it's in a ring. Prop, there's 3, and ANE tells me there's all single bonds. And that's when I was telling you there's a prefix, there's a root name, and then there's an ending. This tells me it's a ring. This tells me there's 3, and this tells me it's all single bonds. Okay, so pretty much everything you write in there tells you. Okay. If you have a branch chain of hydrocarbons with 1 or more hydrogen atoms and they're attached, they're not part of the main chain, but they're attached to it. Okay, I'll show you how to name them too. So sometimes what you'll do is you'll have a chain of 5, but then you'll have another group stuck on there. It's not part of the main chain. Because when you're naming them, you always name the longest chain. That's the root. That's the, meth, prop, hex, whatever. And you can see them here. And again, you don't have to worry about it with methane because there's only one of them. But ethane, there's a carbon here and a carbon here. Here's propane, a carbon here, carbon here, carbon here. So these are the structural lines. And again, every time you move, you have another carbon. Okay, so these are, and again, this I got right out of your book. Okay, so you can look it up again. Okay, so this one, I'd go 1, 2, 3, 4. Right? I think that's, yeah, 4. And you guys, it's not but, it's bute. Butane is the stuff that you have in like cigarette lighters, those little burner things. Butane, it's a fuel, but it's made out of 4 and it's got carbon around. So bute means 4, A-N-E means all single bonds. Okay. Here's another one. 1, 2, 3, 4, 5. So that would be pentane. Okay. Here's this ring. So 1, 2, 3, cyclopropane. Okay, cyclo tells me it's a ring. Prop says there's 3, and A&E, all single bonds. Here's 1, 2, 3, 4, 5, 6, cyclohexane. Okay, so when you're naming them, that's, the simple ones. All you do is count the number, and that's its ending, and if it's in a ring, put cyclo in front. Okay, now we have what they call isomers. In other words, because alkanes are single bonds, they can rotate. Okay, later on when we do double bonds, a double bond would stop and it wouldn't be able to rotate. But in an alkane, because there's only one bond, it's like an axle. It can just rotate around. Okay, and later on when we talk about double bonds and triple bonds, they have different rotational forms. They're called conformations or cis and trans. But we don't have those with the single bonds because, again, they can rotate freely. So when they write them, a lot of times they use a zigzag. Like I said, I like to use the condensed form because I know a lot of people get confused by the zigzag. There's lots of examples in your book. Go through them. That'll help you quite a bit. Okay. But if they have the same molecular formula, in other words, they have the same number of carbon and hydrogen, but they have different bonding arrangements, they're called structural isomers. And again, I'm going to show you several on the next slide. So they have the same amount of carbons, they have the same amount of hydrogen, but they're in different arrangements. Okay. And again, because they have different arrangements, they have different physical and chemical properties. You wouldn't think it would be a big deal, but it is. It changes their properties and what they'll react with and so on. Okay, I'm sorry this is blurry, but I just copied it. All right, here we have, and I didn't put in the hydrogen. Okay, just pretend the hydrogen are all here, but if I put them all in, then it wouldn't fit on one slide. But anyway, we've got 1, 2, 3, 4, 5. This is the longest chain. I know there's 6 there, but this is the longest chain, so it's just pentane. Now this group, because it isn't on the main chain, okay, we have to name it. We have to say where it's at. This is the locator, the second carbon, and this is just a one. When you have a substitute group, that isn't the main thing, because if it was just this would be methane. But it's not the main group. This is. So this is called methyl. If this was made out of 2, it would be ethyl. If it was made out of 3, it would be propyl. So if you've got something added on and it's not the main, on the main chain here, then its ending is YL instead of ANE. So to name this, I'd say 1, 2, 3, 4, 5, that's pentane. And on the second carbon, I have a methyl group. Okay. Now here, these guys are isomers. They all have the same number of carbon and hydrogen, but because their arrangement's different, they're different compounds. Here again, we have pentane, but now the methyl group got moved over to the third carbon, so it's 3-methyl pentane. Okay. Here we have 2 of them. Now when you have 2, because this is my main chain here, this is butane, but I have 2 methyl groups. Well, I can't just say 2-methyl. There's 2 of them, so it's 2,2-dimethyl. If there was 3 of them, it would be 2, like if I stuck another one here, it would be 2,2,3-trimethyl. Okay, so when you have more than one, you have to say where they're at, and these are on the same one, so you just put 2 twice, and then dimethyl. Okay, if I had a methyl group and an ethyl group, let's say I had an ethyl group over here, I would say, 3-ethyl, 2-methyl, or whatever. You have to say where everything is, and when you put them, the substitute groups, you do it in alphabetical order. Okay, here's another one where I have 2 And I separated them. You know, these two are together. Here it's 2,3-dimethyl. So again, on the second and the third, and there's only 4, that's my main chain, but it's 2,3-dimethyl. On the second and the third, there's methyl groups. Sorry, I had to dump those in there. When I copied this, I kind of cut off the bottom, so I just threw those. They're right there, you guys. Just pretend I did that right, okay? So again, whenever you're doing these groups, you have to say where they're at. Okay, so that's it for now. We're just going to start easy. Okay, if you're going to draw these, you guys, if I say draw 2-methylpentane, draw your 5-carbon first, put in your methyl group, and then go back in and put your hydrogen. Okay, here you'd have 3 hydrogen because it only has 1. This one already has 3, so it only needs 1 more. This one has 2, so it'd be H2, H2, H3. And again, if this doing the condense confuses you, just put in your 4 lines and put your hydrogen around, because every carbon has to have 4. Okay, so that's how you do when you have these groups. And we're going to start simple with the cycloalkanes and the straight chains. There'll be an assignment there. I have it in there. It'll be like the one with the common where you don't have to download it if you don't want to. You can just write out this stuff and send it back to me. Okay, so we're going to do that for quite a few of these problems. So again, if you're having issues with it, you got to let me know right away so we can get that straightened out. So this is the second part, just starting with the simple naming the compounds.